Don't feel like doing anything. I just wanna lay in my bed.
Good morning, everybody. Intro music. How about that? Awesome. Well, hope everybody's having an amazing morning thus far. We're going to get into some transformations today. Topic transformations. Very simple to do. Transformations just mean that you're moving things left, you're moving things right, you're flipping things upside down. What you're really doing is you're taking specific points of a graph, like these points we've listed here, and you're moving them. That's basically what a transformation is. So we're going to go over a couple of different transformations here. So let's say we start with this graph here. These are our x-coordinates and our x and y's for this specific graph. And remember, everywhere that there's a turn or a major event happening, I'm going to take my point. So -5, -4, -3, +4, -1, +4, 2, -2, and 5, 2. Excuse me. So anywhere there's a major event, that's where we're going to take these points from. So the first one here, we're going to go ahead and do the transformation, and then we're going to label it. So we're going to do it, and then we're going to actually label what type of transformation it is. So there's a couple of things I want you to kind of get from this. On number 1 here, we're taking y is equal to f of x, and we're subtracting 2. F of x minus 2. Now, if you think about that, we said that f of x is your y value, right? And then you're subtracting 2. So wouldn't this transformation really be subtracting 2 from your y value? That's really what you're doing here. You're subtracting 2 from y. So if I look at these points right above here, I've got -5, -4. So that point is going to become -5 and subtract 2. Here's some -6. And then -3 is the same. 4 will become 2, right? -1, 4. So that'll become -1, 2. 2, -2 will become 2, -4. And this will be 5, 0. Now this, again, this is subtracting 2 from your y values, right? So let's graph these points. Let's see what this looks like. We've got 5, -6 here, -3, 2, -1, 2, 2, -4. Oh, wait, I'm sorry. Yeah, 2, -4 here, and 5, 0. So as you're going through, remember to use your IDs. As you're going through and you're drawing these, what you should be looking at is what has this transformation done to the graph? What am I looking at the graph transforming here? Or in other words, how is it moving? What's the difference between this graph and this graph, my original and my new? Well, if we're looking at this graph, this whole thing really just shifted down 2 units. And that's what happened, right? It was up here, now it's down here. This point was here, now it's here. This point was here, now it's here. So really the whole thing just shifted down 2 units. So that's what we're going to say. This is a shift down of 2. We shifted down 2 units. Okay? So again, what you're looking for here is what is the difference between your new graph and the old graph. All right. Now I'm going to start something here that you're going to hear me say time and time again. On number 2, if you look at number 2, we have y is equal to f of x minus 2. Your first instinct is going to be to take all your x's and subtract 2, but that is not the case. I want you to put a little star right here beside your notes. Put a little star there, and I want you to write, always do the opposite inside the parentheses. Always do the opposite inside of the parentheses. Now, I'm sorry, parentheses, that's SES, that's multiple. Now, the reason for that is you're trying to keep X the same, you are trying to keep your Y value the same. Now, in order to do that, instead of subtracting 2 right here, where it says X minus 2, what this actually is going to do for you is add 2 units to your X values. And I think it'll make more sense once we name the transformation down here. But for right now, I want you to do this. Just write down add 2 units to X. Now again, the idea is that you are keeping your Y values the same, right? You want it to be Y is equal to something. Now the transformation here, if it's X minus 2, since we're adding 2 units to X, I can go ahead and tell you the transformation. This is going to be a shift right 2 units. A shift right 2 units. Now this, I will tell you, this is going to be a longer video. They just take a little practice, that's all. So take your original points, which were -5, -3, -1, 2, and 5 for your X values, and add 2 units to them. So -3, -1, 1, 4, and 7. And your Y values are going to stay the same. Alright. Now I know this is it's kind of counterintuitive because you want to just take X and subtract it. But remember, what you're trying to do is keep your Y values the same here. In doing that, you're trying to think about what will it take to make this thing to counteract this -2. That's moving it right 2 units. Once we actually start graphing equations, it'll make a lot more sense, trust me. Alright, so let's graph these let's plot these. So -3, -4 here, -1, 4, 1, 4, 4, -2, and 7, 2. Again, very straight, always drawing straight lines here. Straight enough. That's a shift right 2 units. And again, you will see this as we go along. So really, if you can just remember that anything that's inside the parentheses, you do the opposite, you'll be good. You'll be set. All right? So let's get into some other stuff here, some other trouble. You'll notice they have your XY table up here in the corner for you just for ease of use. Let's say we have y is equal to 2 times f of x. What does it look like we're doing? We're taking 2 and multiplying it by y, right? So this is like saying 2 times y. So let's take our y values here. Your x values are going to stay the same. Your y values are what's changing. So I'm going to take -4, now it's -8. Take 4, right? Now it's +8. Take 4, now it's +8. Take -2, now it's -4. Take 5, or excuse me, take 2, now it's +4. Plot your points, let's see what it looks like. Where are we at? -5, -8 right here. -3, +8 up here. -1, +8 up here. 2, -4. And 5, +4. So what did that do to your graph? Connect your dots real quick. If you need to pause the video, please feel free to. Take your time on this. I'm going to try and make that a little bit thicker. Connect your dots. And what really happened to your graph here? Compare this to the original. Here's the original, right? Looks normal. And then here's this one. What happened to it? Well, this is twice as tall as it was, right? It's twice as tall. What we call this is a vertical stretch. Vertical stretch, or y times 2. It's a vertical stretch. You're taking your y's and you are stretching them across the axes by 2, by a factor of 2. Okay, vertical stretch. Okay, let's get to 4. You see something in the parentheses here? Automatically, that tells you that you need to do the opposite. So if we're starting off multiplying 2 times x, what would the opposite of that be? I want to divide by 2. Divide by 2. Now, what am I dividing? I'm dividing x by 2. I'm dividing my x value. So your y values here are going to be the same as the original. Negative 4, 4, 4, negative 2, and 2. But your y values are going to be divided by 2. So negative 5 halves, divide that by 2. Negative 3 halves, negative 1 half, 1, positive 1, and 5 halves. Is it okay to leave them as 5 halves and 3 halves and 1 half? Yes, leave them. Ain't no point in writing them as decimals. The only time you ever write a decimal is if I give you a decimal at the beginning. If I don't give that to you, then write it as a fraction. Okay, so what will this graph look like? Negative 5 halves, negative 4, so that's negative 1, 2, 3, 4, 5 halves, negative 4. Negative 3 halves, positive 4. Negative 1 half, positive 4. 1, negative 2. And 5 halves here, positive 2. Oops, right here. All right. Let's draw our graph here. There we go. So compare that to the original, and you see that what happens is it shrunk horizontally. We kind of took it and compressed it horizontally. We pushed it all together. We call that a horizontal shrink. Horizontal shrink. And you are taking x and dividing it by 2. So vertical stretch up above it. If this happened to be dividing by 2 instead of multiplying, kind of like in number 5 down the page there, which you'll see in a second, we'd call it, there's a couple of different names for it, but you can call it a vertical shrink is fine. Vertical compression is fine. Shrink, stretch, those are usually the ones we stick with, but compression and expansion, those both work. Let me run through this one real quick. We have 1/2 f of x. That means I'm going to do 1/2 of y. So now I'm going to take my y values and cut them in half. So my x values are the same as the original. Remember, everything is done based off of the original. Now my y values are cut in half. So negative 2, 2, 2, negative 1, and 1. Plot your points. Let's see what happens. Negative 5, negative 2. Negative 3, 2. Negative 1, 2. 2, negative 1. And 5, 1. So now, once we connect these, what we see here is that the shape is the same width as it was before. It's just that now it's much shorter, vertically that is. It's like we took this whole thing and compressed it. We shrank it vertically. So we're going to call it a vertical shrink. And we're taking y times 1/2, or you can think of it as y divided by 2, right? Taking y and dividing by 2. Okay, so vertical shrink, horizontal shrink, vertical stretch, so on and so on. Let's go to the back page. Let's keep doing some of these here. This is the original again. Same thing as on the front. Now we have 1/2 of x. So originally we were dividing by 2, right? So, or multiplying by 1/2. So what are we going to do to counteract that?